आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, question says that draw the graph for the function f of x is log under root 1 minus x square, and we have to find the range of this function also, and then we have to find the values of k if f of x has two distinct real roots. So let us first draw the graph for function. For that we have given the function log to the natural base under root 1 minus x square. Now to draw the graph for any function, we must follow some steps that are, so first we have to simplify the function that we have given. So it is already given in the simplest form. Now we can find out the domain for this function, because we know log function is defined only for positive values. That means under root 1 minus x square should be strictly greater than 0. That means 1 minus x square is greater than 0 and 1 is greater than x square. That means x should be greater than, this should be less than 1, but it should be greater than minus 1. So domain of the given function is open interval minus 1 to plus 1, in which this function is defined. So now to draw the graph of the given function, we first have to differentiate the function so that we will find the critical points, and critical points will give us the interval in which the given function is increasing and in which interval it is decreasing. So let us differentiate f of x with respect to x. So this will give f dash x. Now the derivation of log function is 1 upon under root 1 minus x square. Then by chain rule, derivation of under root 1 minus x square will be, this will be 1 upon under root 1 minus x square, and this is 1 by 2 in the multiplication. Now the derivative of minus x square term will be minus 2x. So this is 2 and 2 will cancel out, and we will have minus x divided by under root 1 minus x square. Under root 1 minus x square will give 1 minus x square. This is our f dash x function. So on taking minus in the denominator, this will become x upon x square minus 1 f dash x, where x we know we have defined the domain. X is lying from minus 1 to 1 open interval. Now we will put f dash x is equals to 0 in order to find the critical points. So x upon x square minus 1 is equals to 0. This is x is equals to 0. So the critical point is x is equals to 0. Now we have to divide the number line by the critical point. We know critical point divides the number line. So this is the point 0, and we know we have to take the domain from minus 1 to plus 1 only. So for this interval from minus 1 to 1, x equals 0, the critical point has divided the interval in two sub-intervals, that is minus 1 to 0 union 0 to 1. So let us check the nature of the function in the two intervals. So for the interval minus 1 to 0, if we check the value of f dash x, so let us put any random value that will be a negative value here. Let's say minus 1 by 2, and we will put minus 1 by 2 in the f dash x value. So when x belongs to this interval, then f dash x, which is x upon x square minus 1, will be greater than 0. If we put minus 1 by 2, then this value will become minus 1 by 2, and This will be square of 1 by 2, that will make it 1 by 4 minus 1, that is the denominator will have a negative value. So negative and negative will cancel out, that means we will have f dash x positive. Similarly, if we take x in the interval 0 to 1, so from 0 to 1, if we put any value, so this value should be in the open interval. So this is x by x square minus 1, and that will be less than 0 when we put any value from 0 to 1. So this will be less than 0, that means it is positive, and it is negative, that means the function is increasing in the interval minus 1 to 0. We know the nature of function is f is increasing, and here f is decreasing. That means by using the first derivative test, we can say that the function has maxima at x is equals to 0. By first derivative test, we can say this. So that means the function is first increasing from minus 1 to 0, then it is decreasing from 0 to 1, and it is attaining its maximum value at 0. So let us draw the graph now. Now clearly this function is not defined. This function is not defined at the values minus 1 and plus 1. So if we take limit of function when x tends to minus 1, then log of under root 1 minus x square. This is the function when the limit is tending to minus 1. Then this value will be log 0, and log 0 is minus infinity. And similarly, if we take limit x tends to 1 for the function, so this will again be equals to, for the log function under root 1 minus x square, that will again be 0. So log 0 will again minus infinity. That means we have x equal minus 1 and x equal plus 1 as our asymptotes, vertical asymptotes. Now we can draw the graph. So this is the graph, and since the function is defined from minus 1 to 1, and at minus 1 and plus 1, it is attaining asymptote. So if this is the vertical asymptote at minus 1, and if this is the vertical asymptote at plus 1, then this is the point minus 1 and this is the point plus 1, then the function is first increasing, then it is attaining its maximum value at x is equals to 0, then it starts decreasing for the values from 0 to 1. So this is the graph for the function that we have. Now we have find the graph. We have to find the range of the given function also. So the range will be, if we observe the graph, it is clear that the function has its minimum value minus infinity. It is going till minus infinity, and its maximum value is 0. So we can say that range for the given function is from minus infinity to 0, and it is attaining the value 0 also at 0. So this is the range. Now we have to find the values of k if f of x has two distinct real roots. Now for f of x to have distinct real roots, that means f of x is equals to k has distinct real roots, that is f of x minus k is equals to 0. So this is f of x and minus k, that is there is value of f of x, y is equals to k. So y is equals to k will be somewhere here, or it can be here. So there can be many values for k that will pass through 2 points for the given graph. So there are 2 points by which k is intersecting the f of x function. So we can say that these values of k are lying in the negative y-axis, and also they cannot be equals to 0 because at 0 they are intersecting just at one point. That means the value of k should lie from open interval 0. So it is from minus infinity to 0. That is, k should be less than 0. So this will be the possible values of k for the function to have two distinct real roots. So this is the answer. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।